Welcome back to Infra Explained. In this episode, we're tackling a question that sits at the heart of modern cloud work. What exactly is infrastructure as code? The short version is right there. You describe your servers in a file. Instead of clicking through a cloud console to spin up machines, networks, and databases, you define all of it in code. And that one shift from clicks to code changes almost everything about how teams build and run systems. So let's start with the problem this whole idea is trying to solve. Picture the old way. You log into a web console, click through menus, pick a region, size your server, attach some storage, and you're done. It works, but only once. Nobody remembers the exact sequence. Every environment drifts a little, and rebuilding from scratch becomes days of careful clicking. The question naturally becomes, what if all of that lived in files you could version, review, and replay on demand? That's exactly where infrastructure as code comes in. So here's the whole idea in a single sentence. Infrastructure as code means describing your servers, networks, and databases in plain files and letting a tool read those files to build everything for you. The shift is subtle but powerful. Your infrastructure now lives as text you can version, review like any pull request, and rebuild identically whenever you need it. To make that shift concrete, picture this. Clicking servers together in a console is like sculpting a sandcastle by hand. Everyone is unique, fragile, and pretty much impossible to recreate exactly. Infrastructure as code flips that around. Your code files are the blueprint. The infrastructure itself is the building. The IAC tool plays the role of the contractor, and a single command like Terraform apply lets you put up the same structure again and again, anywhere you need it. And once you have that blueprint, the next question is, how do you write it? There are really two styles. The imperative way is a recipe. Do this, then that, then this, and you're responsible for the order, and rerunning it can create duplicates. The declarative way, which is what most IAC tools use, just describes the end state. One server, this size, port 80 open. The tool figures out the steps, and running it again is safe because it only changes what's drifted. So here's what declarative actually looks like in practice. This is Terraform. A few lines saying, I want an AWS instance, this machine image, T3 microsize, tag Dargslan web. That's it. No clicks, no console. This file is the server, and because it lives in Git, you get history, code review, and the ability to roll back a server the same way you'd roll back a bug fix. And that file fits into a 4-step rhythm that's the same across pretty much every IAC tool. You write what you want, then run plan, which shows you a diff of exactly what's about to happen. No guessing. If it looks right, you apply, and the tool reconciles reality to match your code. Then you commit. So the change is reviewed and versioned just like any other pull request. That plan step before apply is the magic. You always see the change before it touches anything real. Now, how does the tool actually know what to change? That's where state comes in. The tool keeps a little ledger, a state file, that tracks everything it's already built. When you run plan, it's really doing a three-way comparison. Your code says what you want, the state says what exists now, and the diff is just the gap between them. One quick warning though, guard that state file carefully. It can hold secrets, and if you lose it, the tool essentially forgets what it owns. So with state out of the way, let's zoom out and ask why teams actually go through all this trouble. 4 big payoffs. Repeatability. Your dev, staging, and prod environments come out identical every time. Versioning. Every tweak lives in Git, so rolling back is just a revert. Reviewability. Infrastructure changes go through pull requests, exactly like application code. And fast recovery. If something burns down, you rebuild the whole environment from scratch in minutes, not days. Those payoffs rest on 2 ideas worth naming directly. The first is immutable infrastructure. Instead of patching a running server, you build a fresh one from code and swap it in, just like we did with containers in the Docker episode. No snowflakes, no servers with mysterious histories. The second is configuration drift. What happens when someone SSHs in and tweaks things by hand? Suddenly, reality and your code disagree. The good news? IAC tools can detect that drift and pull things back in line, keeping your code as the single source of truth. Now, when people say IAC, they're actually talking about two related but distinct jobs. Provisioning is about creating the infrastructure itself, the servers, networks, databases, load balancers, and that's where tools like Terraform, OpenTofu, Pulumi, and CloudFormation live. Configuration is the next layer. Once a server exists, what runs on it? Which packages, files, services, and settings? That's the world of Ansible, Chef, Puppet, and Salt. Same philosophy, different layer of the stack. And in real setups, you'll often see them working side by side. And this is where it all clicks together across the infra series. IAC lays the foundation. It spins up the servers and the cluster itself. Kubernetes then steps in to orchestrate what runs where. Docker images become the actual workloads riding on top. And CI/CD is the glue that automates the whole pipeline end to end. Think of IAC as the blueprint. Everything else is what you build and run on that ground. Before we go further, let's clear up a few myths that trip people up. First, IAC isn't just for giants. Even a single server pays you back the moment you need to rebuild it. Second, it's not a glorified install script. It's declarative and stateful, meaning it tracks what exists and reconciles the gap. And finally, once you've applied your code, resist the urge to tweak things in the console. Those hand edits cause drift, and suddenly your source of truth is lying to you. Speaking of trust, let's talk security, because code that provisions cloud infrastructure is also code that can leak it. Keep secrets out of your repo. Encrypt and lock your state file, and run a scanner over your IAC to catch misconfigurations before they ship. And on the other side, no hard-coded keys, no state files in public Git, no wide-open cloud roles, and never apply straight from your laptop without a second pair of eyes. So, which tools will you actually run into out there? Terraform is the de facto standard, with OpenTofu as its fully open-source fork if licensing matters to you. Pulumi lets you write infrastructure in real languages like Python or TypeScript, while CloudFormation is the AWS native option. Ansible handles the configuration side, what goes on the servers once they exist, and Chekhov or TFS8 are the scanners we just mentioned for catching security issues in your IAC. So let's pull the key ideas together. Infrastructure as code means your servers and services live as versioned files, written declaratively. You describe the end state and the tool figures out the steps. You preview changes with plan, commit them with apply, and the state file keeps track of what actually exists, so guard it carefully. And above all, treat the code as your single source of truth. The moment someone makes a quiet change in the console, drift creeps in. Now, with all that in mind, when does IAC actually earn its place? It's a great fit anytime you're running real cloud infrastructure, juggling multiple environments like dev, staging, and prod, working in a team that reviews changes, or managing anything you'd absolutely hate to rebuild by hand, but it's overkill for a quick throwaway experiment, a single managed service with nothing around it, a tiny project where the learning curve just isn't worth it, or pure local development. Pick the right tool for the job. If this episode clicked for you, there's a whole Infra Explained series waiting, covering Docker, Kubernetes, CI/CD, the deeper cuts of infrastructure as code, and how containers really compare to virtual machines. And one quick word of caution, IAC builds your servers, but a misconfigured template ships insecure infrastructure at scale. Hardening both your code and your hosts isn't optional. You'll find courses on all of that over at Dargslan.com. Before we wrap up, I'd love to hear from you. Are you Team Terraform, all in on Pulumi, automating with Ansible, or honestly, still clicking your way through cloud consoles? There's no wrong answer here, and the comments are the best place to compare notes. Drop your tool of choice below and tell me what's working, what's painful, and what you wish was simpler. And that's a wrap on infrastructure as code. Zoom out for a second. Docker, Kubernetes, CI, CD, and IAC really are the four pillars of how modern teams ship and run software today, and we've been working through them one piece at a time in this series. If you want the rest, hit subscribe and come find more deep dives over at dargslan.com. Thanks for watching. I'll see you in the next one.